Hey there, we're Mainmiller, a consultancy that helps teams and companies to adopt Rust in their engineering organizations. And we're also a new group of contributors to the Rustacean Station community podcast. We're going to be releasing a number of interviews with great authors and people using Rust professionally over the coming month. You can also find a link to the video of the conversation in the show notes. Enjoy!
Hello everyone, and welcome once again to another episode of the Rust interview series. Today we're joined by Vitaly, a developer advocate at JetBrains. JetBrains has been developing tooling for Rust for the past few years, and today they're here to talk about a big change. They're launching a new IDE focused on Rust, and Vitaly will tell us more about that IDE and more generally about JetBrains' involvement in the Rust ecosystem. Hello Vitaly.
Hi Luca.
Well, first and foremost, thanks for coming. I would like to kick this off by having you tell us a little bit about yourself and what you do at JetBrains.
I work as a developer advocate at JetBrains, but most of my time I was a university lecturer. So I was teaching programming languages, other topics in computer science, and I'm a junior developer advocate. So I'm here a little bit more than a year. So very junior.
It's interesting. What led to this career transition?
Well, Russia invaded Ukraine, and I had to leave Russia. And I was working at JetBrains before that, but I worked at an educational program in St. Petersburg University in Russia. But then JetBrains left Russia, and I left Russia too. So I thought that maybe switching to something different from education is also a good idea. So I did that. So I had a very big background in programming languages. So I thought that developer advocacy is the right thing for me.
And what does a developer advocate do in a company like JetBrains?
Well, as a company, we sell tooling for software developers, right? So advocacy means helping developers to solve their problems. Well, sometimes using our tools, but maybe using some other technology we know about. So our job is mainly to disseminate knowledge about technologies and tooling that can help with that technology. And this includes conference talks, blog posts, sometimes writing books, whatever. So all sorts of activities, how to tell others about new technologies, new tooling, and stuff like that.
And how does Rust specifically come into the picture? Because that's fundamentally what we're here to talk about.
When I was discussing with my potential manager, Heidi Hariri, our chief developer advocate, we were discussing several programming languages. I was telling him, well, my main programming language at that time was Haskell. I wrote a book about Haskell. I taught many programming languages in my university times. Once I was trying to count them, and it was 20 programming languages for 20 years. So that's a long period. So we were discussing some programming languages I can be useful for at JetBrains, and Haskell unfortunately was not that sort of a language. But then I mentioned Rust, and he said that, well, that's interesting because we have a team working on Rust at JetBrains, so maybe it could be interesting to do something about Rust. So that's it. I never taught full course in Rust before, but I was giving several introductory lectures, so I knew something about Rust. So that's why I started doing Rust. It's not my full responsibility to do everything about Rust, but I have some other responsibilities too at JetBrains. But Rust is one of the points of my work at JetBrains.
I'm curious, how are you finding the transition from Haskell, which is purely functional programming language with a certain approach, to something like Rust?
Technically, I don't do a transition because for me, programming languages were always objects to learn and to teach and to talk about. So I never did professional software development in Haskell, and I don't do professional software development in Rust either. But for me, these are just, sometimes different, sometimes very close to each other programming languages. So of course, it's interesting to compare feature by feature, but in general, I don't do transitions. I just know a lot about both of them.
I guess from an education standpoint, right? The type of people that come learning the language and the type of obstacles that they might face in the process might be fairly different. At least I imagine. I've never taught Haskell before. I've taught Rust and Python. And, it's a fairly different type of experience. So that's more the angle I was coming from.
Well, that's true. So the languages are really very different. But you know what? It's interesting that when you're used to one style of programming, like if you're doing everything in functional style, I was surprised that in Rust it is very possible too. Like I'm enjoying coding in Rust in functional style, like similar to Haskell. So that's the main reason is that Rust has a lot of roots from OCaml. And OCaml is very close to Haskell in terms of functional programming and in terms of concepts of functional programming. So in that sense, it was pretty close. But of course, everything regarding memory management is totally different. And this is something I had to learn from scratch when transitioning to Rust in that regard, because we don't have that memory management in Haskell.
And I guess also the big difference is that I think the functional style in Rust is fairly nice, but then higher order candid functions are not as nice and not as ubiquitous, at least in my experience, compared to what you would have in like Haskell or Camel.
I wouldn't say they are not that nice. Well, sometimes it's difficult to write code in that way if you want to keep like your memory under control, but that's still possible when you use something like iterators and you write those chains of calls, and then you provide functions for map, for filter. Well, it's pretty functional.
I don't know, from that point of view, I agree with you. I think the angle I was coming from is where you're trying to write yourself higher order candid function. Writing the signature in Rust immediately projects you from like a beginner level to a fairly advanced like user of the type system. You have all the function traits, and then you start to have generics, and like the thing is a lot more involved than what you get, for example, in Haskell.
That's true, but in Haskell we are used to sophisticated type signatures, so it's not a problem.
That's true as well. So going back to the JetBrains side of the conversation. JetBrains has been investing in the Rust ecosystem for a few years. I've personally been using on a daily basis the IntelliJ Rust plugin in either CLion or the IntelliJ IDE. And the big news is that you're launching a new IDE, which is Rust specific. And so my question is, what led to that decision, first and foremost? And what is that Rust-specific IDE bringing to the table that we didn't have before?
Yes, we at JetBrains, we were thinking about Rust for a long time. And actually, a lot of our customers were asking us, where are you going to launch a dedicated Rust IDE? Like for years, we were getting this question. And then we were analyzing everything about programming languages, actually. So we know a lot about them. So we are looking at surveys. We are looking at what folks are doing with those programming languages. And while doing all that, we were constantly like checking the current situation. Like, is this ecosystem mature enough so that we can provide something dedicated for this particular ecosystem, for this particular community? And of course, the decisions like that are not very quick. Like, you need years to analyze everything, and you need years to come up with a decision. So, we did that. So we did that constantly. But then we realized that, it looks like Rust ecosystem is ready, and we are ready to invest more in it. So, like looking at numbers, you see that the Rust community is growing, Rust applications are growing, and you have a lot of libraries for whatever you want to do. And that means for us that we can enter this market and we can provide a commercial product specifically for Rust developers. So for us, well, we just think that Rust is ready for that. So that's why we've decided to launch that new IDE.
I see. And going back to the question, what does that mean, like compared to what you're offering today?
There are two sides of this question, actually. So if we are talking about regular developer experience, like in C-Lion, for example, then we can say that right now we don't have much more than C-Lion with Rust plugin. Well, it's an IDE with Rust, everything included. So we have like everything we had in our plugin, but we also bundle it with other JetBrains tooling like databases, HTTP clients, so everything for web development, teamwork, for example, like web technology. So we are bundling a lot of stuff into one product so that any developer can just download it and do what they want. So no need to configure something, no need to spend time preparing to work. Just download and open your project and start doing your job. But another side, which is more important for us, is that having dedicated product means investing into this particular market. Like we can hire more developers to work on that. Like in terms of JetBrains, we could have a bigger team. We can start solving problems which were not solving before because of the lack of the resources, right? So now JetBrains is starting to give more resources to the team. And that means that in the nearest future, we can implement much more features. We can improve an experience. We can provide more stuff for the developers. So that's an idea. So everything included, you have out-of-the-box experience, and we are providing more. So we're investing, and as a result, we can provide more features in the very near future.
So it's fundamentally a signal that JetBrains is entering this market to stay, like in a medium to long term. And the experience is, could I call it like more Rust native in the sense that you don't have an interface which tries to cater to multiple languages, but instead it's tailored to what one would do if one was working on a Rust project?
Yes, you're right. So when you launch a new project, you just create Rust project and you don't have anything else in your IDE. So it is dedicated. And then, well, of course, JetBrains is very serious by coming with such a product. So we think that this product can be helpful for developers. And once again, so we are providing this experience for Rust developer. So of course, it's when you say Rust native, like we at JetBrains call it like JetBrains native experience for developers. Like this idea that you have every tool in your IDE, it's what we usually provide for other programming languages as well. So we bring this very experience to the Rust ecosystem.
That's very nice. And let's unpack that a little bit further. So obviously we're used to IntelliJ Rust debugging being primarily, at least from what I experience on a daily basis, is a language server protocol implementation. So it provides autocomplete, refactorings, this type of features. But an IDE is like a comprehensive toolkit for developing with a certain programming language. And so I would like to understand your opinion and perhaps your intention when it comes to the broader toolkit for Rust development. So when one thinks of a toolkit, one thinks of debuggers. profilers, running tests from the IDE, being able to set breakpoints and analyze what the program is doing at a certain point. What do you think we are today, and where do you think we're going to be in the future?
That's a very interesting but very hard question for us. We are creating tooling, but then we look at the ecosystem and we look at the surveys and we see that they don't use that tooling very often. Like if you look at debuggers, for example, debugger is a very important use case. I think from the latest State of Rust survey, which was done by Rust Foundation, 80% of developers don't use debuggers at all. So they prefer print line debugging. And I think that is unacceptable. Well, because debugging in IDE is much more powerful. But the problem is that we don't have too many users for this particular piece of tooling. And as a result, it's impossible to develop this tooling even further. Like, if ecosystem doesn't need debugging, then we have limited support in the compiler itself. And we know a lot about those limitations because, well, nobody needs that. So if people start using that tooling more extensively, then that means that we can ask folks from the compiler team to provide more debugging information, for example, and then we can support that information. We can give more to the community in terms of debugging. And the same thing goes about profiling, for example, about testing. So everything. So we need to persuade folks to use more tooling and to give us feedback and maybe to push some other teams out there to make better support for that. By the way, that is one more reason about this experience with dedicated Rust IDE is that it's easier to provide new plugins for this IDE. You have an IDE and you have a framework, like some web framework or something like that. Then it will be possible to come up with a plugin which supports this particular framework, for example. And this is like technically it was possible before, but now it makes more sense. Like you have a dedicated IDE and you can provide support for something specific. If you have some specific testing library in mind, you can provide support for it too inside an IDE. So, of course, we have sometimes in some areas, we have very limited tooling at this moment. And of course, JetBrains is not able to provide everything because we depend on libraries. We don't do Rust programming. We don't do Rust create JetBrains. We depend on the compiler, of course. And with this new product, it is possible to negotiate with all the different folks from the community and persuade them that some of them can use something, some of them can develop something new for this ecosystem, and then we can use all that together. So that's an idea.
Makes sense. When I get back to something you were touching upon, it feels like there's a chicken and egg problem situation when you're like, the tools are not great. Folks are not using the tools, probably because they're not great. Therefore, the tools don't improve and they stay not great and folks keep not using it. And you mentioned print line debugging, and I think that's a very interesting example. So I'll bring my own, personal experience. I do a lot of, print line debugging in Rest, which is usually like with logging, not necessarily with print line. But for example, beforehand, I was working in C#. Once again, using Rider, which is another JetBrains IDE. And in Rider, I was using the debugger. And so it's like, it feels there's an element that's very cultural to the ecosystem you're operating into as to what are the common practices that developers kind of reach for when they need to troubleshoot when something goes wrong. So I do wonder, like, obviously there's an element of quality of tooling. Like, is the tooling good enough, easy enough to use so that folks can jump onto it? But is there perhaps also an education gap that just people don't know what tooling is available and like how to go about reaching it? Specifically around debuggers, I think, in this case.
Well, you said quite an interesting thing. So you said that you don't use print line debugging because you use logging. And that is actually says something about you. So if you are able to come up with logging, which provides you enough information to avoid print line debugging, then you have good logs.
Yes.
But in general, we see something different. Like if you use print line debugging, then you just put that print line somewhere, compile your program, and then you see that you don't get enough information from this run. So you put another print line, you compile it again, and then run again, and then you spend a lot of time. And if you think about the size of your project, the time that you need to compile that project, and if it's a real professional project and it takes minutes to recompile it, or maybe dozens of minutes, I don't know, in that case, you are really in trouble with your usual practice of print line debugging. It's great if you have logs for everything, but it's not usually the case. I think that it's not only about the quality of tooling and education, it's also about the level of applications we are actually doing in Rust. So once we have more large commercial projects in Rust, projects where it's just impossible to recompile the project every second, then we just have no other options except for using some professional tooling, including debuggers, profilers, and everything like that. And in those large projects, print line debugging is not an option. So we see that community is growing, but we also see that there are more commercial applications. And that means that the size of those projects is becoming larger. And then we'll see that folks will start using those tooling. So in situations when print line is not enough, is not accessible because of times for recompilation. And then, of course, you're right. We have to educate folks about that. When you do debug, you can experiment with your values. Like, I like this feature a lot. If you have a variable, you can just change its value right when you stop at breakpoint. This is very powerful. This is something that is impossible when you are doing print line debuggers or even loggers. So if you are implementing some algorithm, this is extremely valuable to be able to change values. And if we are speaking about .NET ecosystem has very powerful debuggers. Like, it's possible to do reverse debugging, for example, like going backwards and to understand how do you just come to this point to trace everything backwards. Very powerful tool. This is something we can do in Rust at the moment because of the limitations in tooling, but also in the information which is generated for that tooling by the compiler. Once we have larger projects, we'll have more requests for professional tooling. And we are here to fulfill those requests because that's what we do. So we did that for Rider, for C#, we did that for Java, and we are definitely ready to do the same thing for Rust.
I mean, that makes a lot of sense, right? When you have a project that's just too big to recompile, try something, recompile, try something, then you definitely need to reach for something more sophisticated. Interestingly, I think one such project that is around at the moment is the Rust compiler itself, which I have partially contributed to in some bits and pieces, and definitely like print lining and recompiling is not necessarily the fastest loop. And I do see that, for example, they try to rely on more advanced debuggers. If I remember the name correctly, that's Pernosco, that is sometimes used in the Rust compiler itself to do that kind of like debugging, interactive debugging, and also replaying. So being able to record one run and then kind of inspect different points and information. So it'll be interesting to see how this thing plays out as the more commercial footprint increases in the ecosystem. Speaking of which, what's your forward outlook? Like if I ask you, where do you see Rust as a language and as an ecosystem going a couple of years into the future? What do you see?
Well, definitely I see a bright future.
That's good.
Well, otherwise we wouldn't come into this market. Like several months ago, maybe in February, I wrote an article for InfoQ where I tried to review many surveys. And when you look at the surveys, you feel that there is bright future indeed, because we see that every piece of ecosystem is growing. So, and I don't see any trends in the reverse direction. And there is one important thing here. When Rust was originating, like many years ago, people were often talking about Rust as a C++ killer, like language which is going to replace C++. But apparently, it's not the case at the moment. And moreover, it's not something anyone needs. Like there are many projects with C and C++, and they are just fine. They can use Rust to rewrite some of the critical components in those projects, not a problem for them, because you can use Rust and C++ in one project. But what we actually see is that there are many folks coming to Rust from other programming languages, not C and C++. We have a lot of Python developers. We have a lot of JavaScript developers coming to Rust because they are interested in that. And they also bring a whole new universe of ideas to implement something in Rust. Web development. I think if we were discussing Rust applications 5 years ago, speaking about web development would be something really awkward. Like, well, this is programming language for system programming, not for some web development, for web frameworks, for implementing routing, stuff like that. But now it's perfectly fine application. I actually think that we'll see more and more applications in the areas we are not thinking about right now. I'm pretty sure that we'll have more application in medicine, like the software for some medical equipment. We'll definitely see something for hardware really low level. We have those projects right now, but we don't have that many commercial projects, commercial applications. But I'm sure that we'll see something like that. There is one thing which I can't say I don't like it, but this is something that I've seen before in other programming languages, mainly Haskell, and I don't like this sort of line of development. Like language is becoming more complicated, and this can be seen as a problem for many developers. Like people in the industry, they don't want to be part of an experiment. So they want to have their language done. Well, not done because they need some new features, but they don't want to have any breakthroughs. And this is something we should be very careful about. So it's what we see in new features can be a good thing, but they can also be not very good thing.
A way to paraphrase that is that people like the language to finish what they started. So, polish existing features and fill in the dark corners didn't get enough love, but I don't necessarily like features that dramatically change the way you actually use the language. Does that resonate with what you meant?
Yeah, that's right. But like if you talk about that with language designers, they will definitely see that they have a lot of great ideas in mind, how to bring very nice features to Rust. And that's not always a good thing.
Yeah, we've seen some pushback as well. Like, I think the Rust project is realizing that they are in the mature phase of the language where folks expect productivity and don't necessarily expect significant changes to the way Rust works. And proposals that dramatically alter the language, I can think about keyword generics as being one of those that generate a lot of discussions in this direction in the past, are generally met, at least with skepticism, so that like the bar for proving that this is a worthwhile addition that justifies the complexity is a lot higher today than it perhaps was 5 years ago, which on one side is obviously positive, on the other side might slow down evolution in the language, but I think that is necessary, as you were saying, if you want to see industry adoption.
That's true. This slowing down is actually a good sign for the industry that the language is mature enough to be actually used by commercial applications, so that they don't need language which changes every week.
Although I think in Rust is an interesting composition because on one side you have the language that is slowing down, on the other side you have the ecosystem that is not as much slowing down yet. And like you want the combination of both to be like a stable platforms for people to develop on, which depending on the use case is and is not the case at the moment. Like it's very specific, I would say, to what you're trying to accomplish.
Right, you've mentioned ecosystem, and for ecosystem, of course, it's very important to grow fast, like to provide more libraries to cover more use cases. This is extremely important. That's true.
So you mentioned before Rust is showing up in different types of applications compared to what one would have expected 5 years ago or 6 years ago when the language first became mainstream. And so it's interesting for me to try to understand, why do you think that's the case? And those people, how are they finding the language? What's their experience with it?
In my opinion, many folks think about Rust that it's somewhat complicated programming language. So they come to Rust with an idea to learn something new, something sophisticated. This is, well, many folks are actually want to learn something complicated because this tests their mental abilities, let me put it this way. So they just want to learn something smart. Rust gives a lot to that. By the way, we know that this learning curve for Rust is quite hard, so we have to spend a lot of time in the very beginning to understand a lot of very complicated concepts. So folks are coming to that, and then they learn about borrow check, about this whole idea of ownership. They depending on their background, they learn a lot about type system, about traits, about generics. So there are a lot of things there. So once again, depending on their background, they have to learn a lot about language, but they also have to learn about potential applications. And if they have some web development in their background, they know that there are so-called web frameworks, and they definitely should find something in Rust, and then they look at something, and then they see completely new ideas, even in something that they perfectly knew before. So this is a challenge for them, of course. For example, in our plans, we have a lot of ideas on how to make this transition to Rust concepts easier. Like we can help in many cases. Like we know that Rust compiler is one of the best compilers in terms of suggesting how to fix the problem. Like I don't know any other programming language, any other compiler with this perfect ability to suggest how to fix the problem. So we can bring this even further. So we can use IDE to give more information about the code, to give more advice on how to fix issues with it. And well, this is something we are going to do. So we have challenges and folks are struggling with them, but sometimes compiler can help them and sometimes IDE can help them.
How is the interaction there between the compiler suggestions and the IDE suggestions? Because obviously the compiler does a lot of ashy art, trying to tell you where things are and where they should be changed with. Is the IDE capable of picking that up and transforming that into, for example, suggestions? Or is that something that's not done at the moment?
Well, we are doing that at some level, but imagine that it's not only about interaction, it's also about visualizing things.
Mm-hmm.
We can try to visualize something in a new way, like life cycles, for example. So you have lifetimes for variables, and you can visualize it. And if you visualize it somehow, you can get more insights on what is the source of an error you currently have at your code. So technically, it's just part of research. So we need to find new ways how to suggest fixes to users. So it's not just something like read this and then you get an idea on how to fix that. No, it's also about showing something like graphically. So this is what is possible in IDE and is not possible when you just talk to compiler.
Yeah, I mean, obviously the terminal is much more limited, type of interface compared to a text editor.
Yeah, just imagine like if you have a code, you can put some layer with additional graphical information on top of your code, like with different arrows, with whatever, some pictures, which helps you understand what's going on in your code. So this is also possible.
Is this conceptual, or is this something that JetBrains is actively working on, if I may ask?
This is part of our job, actually. So we always say that controlling everything inside IDE gives you a lot of ways to deliver information to the user. Like when you compare us with some LSP servers, which are very limited in terms of ways how they communicate with an editor. So you have LSP server, you have editor, and you have very limited protocol. Our approach is different here. We can do everything inside an IDE. And this gives us much more ways to communicate information between user, between IDE, compiler, other tooling. So this is what we are working on right now. So it's not something just a concept.
No, it's very interesting to understand. And going back to the specific challenges and commercial adoption, what do you see? You mentioned web development multiple times, then you mentioned other applications in the medical fields and more embedded type of use cases. Which of these sectors from a commercial standpoint are you seeing on a faster growth path that actually are coming to JetBrains looking for Rust tooling and generally seeing Rust usage expand at a faster pace than the mean across the ecosystem?
Well, I think the easiest area is backend applications. So it's an easiest area to code in Rust, because other areas may require additional certification. For example, we know about the projects in Federal system about delivering certified version of Rust compile, and this is very important. But it takes a lot of time to persuade folks in embedded programming to use something new, and for them, being a language 10 years old in that area is very new. It's just it's not 40 years of C experience. So it's technically takes more time to persuade those folks to do something in Rust. But yeah, it's possible. But yeah, web development is the easiest thing. So that's why we want to bundle everything for web developers in this IDE. But we look closely to other areas as well. So, but it will take more time, definitely.
That makes sense. And what is attracting people to Rust for web development and backend development in particular? Like, from what you hear, what's the key reason for that traction?
Well, definitely performance. That's for sure. And the thing about performance is that in many cases, it's easy to come up with a more performant version of your implementation in Rust. Like if you have some implementation in other programming language, it's easy to come up with a faster version just in the very beginning of the project. Then, of course, if you need even more performant software, you will have to learn a lot about memory management in Rust. You will need to avoid memory copying and stuff like that. But even in the very beginning, it's easy to get a performant version. By the way, I think that that's a problem for our performance analyzing tooling, like for profilers. People don't use profilers because the software is fast enough in the very beginning. So they just don't need that. But once you have an efficient software, well, you will always need something even more performant a little bit later. Like you have something fast, but you will need it faster, that's for sure. So performance is definitely number one. Number two is memory safety. And I always hear that. So you don't have memory leaks very often in Rust. Like despite popular myth, well, it's possible to get memory leaks in Rust, unfortunately.
It is possible, but it's not easy, I would say. It's not common.
It's not common, and that is a very good thing. So you can save on Amazon EC2 instances when you implement your application in Rust. So you can use smaller instances and you get the same performance as before if you're rewriting from Rust. So you have safety, you have performance, and those are two things. But then there is the third reason, and I'm not sure it's the right thing to talk about that, but still, I want to tell you something about that. When I was writing a book about Haskell, my publisher was constantly referring to me saying, well, you have to persuade folks to write code in Haskell. Because, and then he was trying to come up with good ideas like writing good software, like getting more salary and stuff like that. But for Haskell and also for Rust, for many developers, it's just big fun to develop something in Rust. It's fun to overcome those complexities. It is fun to come up with memory efficient implementations. And in Rust, you have all the possibilities to get something like that. So it is really rewarding experience to code in Rust. So that is the third reason for many folks out there, and I believe that. So you just enjoy coding in Rust, and that is important to start new projects and to code in Rust professionally. And if you get a good salary, well, that's just great.
It's a win-win situation, right? We get faster applications and developers get some more enjoyment out of it. But I do wonder, obviously, the objection that one can bring is that there's a lot of languages out there with very complete software development toolkits for backend development. You mentioned Java, I can mention C#. Obviously, there's the JavaScript ecosystem, but also Python and others. Is performance really enough to convince not necessarily the single developer, but organizations, so commercial entities, to think that it makes sense to do that kind of development in Rust?
Well, we have performance, we have security, and we can think of bringing something new into this equation. But we have to also think about the size of this area. Like web development is getting bigger. So it's not that we just try to we have the same pie every year and we just split it into different programming languages. No, the pie is getting bigger itself. So we have more market for that. And so market is growing, Rust is growing, and that means that we are getting more of that pie every year. So we don't have to compete with other programming languages here. Well, we do have to compete, but it's just part of the story. The market itself is growing, so we just need to keep up with that growth and to get something from it.
It's not a zero-sum game. Like, we're not trying to win people over from existing ecosystem in so much as we're trying to make Rust a compelling option for folks who are writing new systems, fundamentally.
Right. Starting new projects in Rust is very good thing, I think. So, and we'll see more of that. Of course, well, there are many like funny pictures about rewriting everything to Rust, but that's not necessary. So folks can just start new things in Rust, new projects, and that's much easier to do these days because we have mature enough ecosystem.
I think we're going towards the conclusion. We covered a lot of ground. Thanks again for coming on the show. That was very interesting. Do you have any closing thoughts that you want to share with who's watching or listening to this today?
Well, yes. I want folks to try our new Rust IDE, and I also want folks to think about using tooling more extensively. This is extremely important. Like, we are creating something for our users, so we expect something in return. So we expect your feedback. And then we'll try to fix everything. If you have some problems, we'll fix them. If you have some ideas on what should be implemented, we are definitely going to do that. Because when JetBrains enters some community, like officially with a product, then we definitely want to hear something from you, because that's what we need, and that's what everyone needs actually, because we can think about that, we can implement something new, and we can deliver some new experience.
Amazing. Well, once again, thanks for coming, and thanks everyone who have listened through this. See you the next episode.
Thank you.